Hello everyone. In this video lecture, we will learn about the very important library for data visualization and plotting the graphs, which is Matplotlib. So here we will discuss the basic functionalities of Matplotlib library, specifically used for machine learning purpose. Here we will explore the pyplot package of Matplotlib library and see how various plots like a bar plot, scatter plot, normal plot, histogram, pie chart, and much more other things. So let's begin. So let me share my screen. Yeah, this is the workbook I have created for Matplotlib. It has a basic plot, then how to label a plot, then how to create subplots, bar plot, pie chart, scatter 2D plot, and histogram. I have mentioned the link for this workbook in the description. And here we will explore 2D plots. For 3D plots, there can be a separate video which will be uploaded in the future. So here we will begin. So Matplotlib, as I said, is a Python library to plot graphs, and we will mostly focus on pyplot package of Matplotlib library. So for plotting histogram, we use Matplotlib library, and for another scatter plot, pie chart, and many other things, we use Matplotlib library. When you get data set, you need to analyze the data set and visualize it. So you will often use this Matplotlib library and Seaborn library. Also, the video for Seaborn library will be uploaded in future. So as normal library, we first import the packages. Here we will use pyplot package, and along with matplotlib, we generally prefer NumPy library, and sometimes many times pandas also. So here we have imported two libraries. So as you know, the plot in basic sense, the plot is the y values versus the x values. So here the basic function of matplotlib is plot. So we will use plt.plot. It takes two arguments, x points and y points, and these are the x points 1 and 5, and y points are 1 and 6. So it will plot the curvature between x points and y points. So first it will coordinate all the x points on this, let x point 1 and x point 5 over here, x point 5, and y points 1 and y point 6, and it will draw the line or the curvature joining them. The curvature can be line or any kind of complex curve as well. Here another example, we are saying that here x points are the uh, points between 100 points between 0 and 10. So this is the built-in function of numpy, so which gives the 100 different points between 0 and 10, equally spaced points. Yeah, so y points are the sine function of these x points. So here if we plot the starting from 0, so it will be sine 0 will be 0, and sine 10 will be this corresponding value, whatever it be. So this is the same plot function which takes x points and y points. Now here we are saying that plot function is taking two values, but we can define plot function taking one value also. Like we have given this list of two plot function. Now what it will do? It will plot the value versus the index. Like it will map the 3 and index at 0 for index 1. It will map 5 and so on. So this is how the basic plot function works. Now if you see this graph, so it has no labeling for let's say for any other graph you are saying. So it is very difficult that what this y value represent and what this x value represent and what are the other things. So we need to label a graph. Whenever you make a graph, you it is good practice that you label the graph properly, so that another person who is seeing your code or seeing your material can get the better idea. So labeling. So here we are doing the plt.plot function. This is the same as we saw above. Now marker. Now marker is what you can see the plus point here. This plus. So this is marker that this graph is represented by this plus. Then color. The color is red for this curve, and level is sine. Observe that here we are having two curvatures. So you can have as many as you want in the plot function. So here for this plot of sine, we are having this marker and this color and the level as sine. Okay. Now for cos, we are having blue and marker as dot and so on. And the x level, here the level is for this curve. You can see here on the top bottom left that it is red one is showing sine and blue one is showing cosine. So this level signifies it here. If I change the name of level here, so it will reflect here. Okay. So x level is written here points, y level is written here sine values. Yeah, here y level is trigonometric function values. So legend is this: sine if we have given level here sine and cosine. So by the way, this is called legend. As you can see on this line, it is legend. So the legend will represent for each curve. Let's say whatever level we have given here, it will represent for each curve. So here it is good practice to add legend. Then title of the plot, that this graph for trigonometric function, and plt dot show at last. So this is used at last, and it basically plots the graph. Okay, that's what I'm saying. Okay, now come to subplot. So this is what I was talking about. So remember, in all the plot we have seen that we have seen only one plot. Now what if we want two plot in one figure? So this is called one figure. So what if we want two plot in one figure? So for this, we have this code snippet. Here exports are this, and we have defined a subplot. Now the first argument of subplot is rows. So number of rows will be 1. Number of columns will be 2. And this plot number is 1. So this will define one subplot, and this will define PLT plot, export and sine of exponents. And similarly for cosine. Now here PLT dot show is used at last. So what it will do? It will first create these two subplots, and at last it will show. Now we are going to see the bar plot. The bar plot is, I think you know that it has on axis, it has levels. In our case, these are subjects like English, math, science, and so on, computer and history. And on the y-axis, we have marks. So for let's say particular student, these are the result, that on x-axis these are subject and y-axis these are marks. So the bar function of the pyplot is used. So this is again x, which is subject, y is marks, color is red, alpha is 0.4. Alpha is used for the how much the what we say opacity is there. Opacity, let's say it is 0.8, then it will be very red, and this is how it is used. And width is let's say 0.5, so how much it should be wide. So this is width, x level, y level, title, and so since there is only one parameter, so I have not used the legend. But when you have multiple graphs, multiple parameters inside of one graph, it is good practice to use legend. This is a bar plot. See, yes, understand this graph carefully. In the previous graph, we had only one parameter. Let's say parameter means 1 marks, but here we have 2 marks, mid sum marks and end sum marks. Subjects are as it is, and these are mid marks and end marks. So we have added 1 bar, same color is blue and alpha is 0.7. We have added another bar for end marks. Okay, and we have added legend. So focus that these are end exam marks, and these are blue are mid exam marks. Now see this carefully. This dark red area shows in common. Let's say English are somewhere around 30. So this dark area shows in common that both subjects have got at least 30 marks. Okay, so we can see both has got at least 30 marks. But this extra blue area, this is pure blue, means pure blue. Yes, this is pure blue. So it shows the extra marks. So in mid, English marks are 70, and this and English marks are 30. Here we see the dark area shows common marks. Let's say both have got at least 50 marks, and the more marks are in end sem. Yes, end marks are having more. So this is not dark red but light red, somehow light red. So this way you can observe the graph, and in computer, both examination the student have scored 100. So this is dark red up to 100. So both subject have equal marks, which is 100. And here we have added the legend, and it is good practice to add legend when we have multiple parameters inside a graph. So this is the thing. Now what if you want to represent this graph in another way, or let's say you have more than 2 parameters. So in such scenario, this kind of graph becomes difficult to read. So in that case, you have this kind of graph. So here same in English, let's say this represent mid marks. So these are mid marks and these are end marks, and so on for each subject. You can have more than 2 subjects here as well. So here let's see, this we have defined the data. It is good practice to define the data first. And here we have bar width. So this is the width of the bar, and we have now we need to arrange the these bars. So we are arranging this bar. This will return a numpy array of 0 to length of the mid marks -1, and this will be that array plus 0.25. let's say this will give length is 5, 0, 1, 2, 3, 4. This BR1 will be 0, 1, 2, 3, 4, and BR2 will be 0.25, 1.25, 2.25, and so on. So here we are having the bar of BR1. So it will be 0 and the mid marks means 0, 1, 2, 3, 4 and mid marks. Other things you can understand. I think we have understood it in the previous graph. And the another line of code of line, it shows that VR2 means 0.25, 1.25, and so on, and end marks. So this is the thing. So this line, what this line will do? This line will add the Yes, this line will add the name of the subjects on this x axis. Uh, Whenever you don't understand any line, do what let's comment it. Without so we don't have this line in execution. Now see this is 0, 1, 2, 3, 4. Now we have this line, so it will use the indexes of 0, 1, 2, 3, 4 as indexes of 0, 1, 2, 3, 4 of subject as the x levels. So we see whenever you find any code, any line very difficult, first comment it and see the difference in the outcome, then break it one by one. Let's say for R plus bandwidth, for R in range of length of mid marks. So R will be 0, 1, 2, 3, 4 and R plus bandwidth, and the subjects is used to print here the different subject, English, maths, and so on. So this is how the bar plot is defined. Now pie chart, you can see that the same data is used, that out of total marks, 31.95% marks are of computer and 12% of marks are from history and so on. So this is how pi function is used. So x-axis we have marks and labels, then autopacity, sorry. Autopacity 1i means integer and no decimal, and 1.2f means float and 2 decimal. So here if we represent as 1i, let's say, so it will be integer only, it will not be float. See, it will be integer only. Now if we have 1.3f, then float with 3 up to decimal. So you can understand this. Now we have scatter plot. It is also very basic plot. We have defined x points. On this is on scatter plot, we define by plt dot scatter x points and np dot sine of x point. So this will be the sine and this will be the cosine. And here s defines the size. Let's say the size is 10, instead of 10 we have 20. So see the difference, we are changing in the cosine. So see the difference. So these are bigger. If you still cannot observe, let's make it 50. See, they are very big. So this defines the size. So let's get back to normal. Yeah, histogram is you will often use histogram when you need to fill the when you need to fill values by mean or median, when you need to standardize or normalize data, you will often use the histogram. So here we can create a histogram by giving the array. So here I have defined the array by using in numpy.random.normal function, whose first argument is mean, second argument is standard deviation, and third argument is number of points. So we are generating 500 different points having mean of 0 and standard deviation of 1 by using this function. So and after we get the x, we simply call the plt.hist function on x, and we at last we saw the histogram. So this is the workbook for Matplotlib. So for 3D plots, they are very rarely used in machine learning application for analyzing the data. Majority of time we will deal with 2D plots only, but I'll upload the separate video for 3D plots very soon. So the link for this workbook you will find in description. Thanks for watching.